Okay, we're finally ready to cover the last piece of the puzzle for this example, and this is going to look at the implementation of the quote client, including the test driver, and you can find that here in the EX2 project in the RSocket folder in the Live Lessons GitHub repository. We're now in the test project for the EX2 case study, and we're going to start by taking a look at the quotes test program. You can see that that is a Spring Boot test, which means that it can auto-launch the quotes application, which will listen at a defined port. And then we go ahead and define some fields and methods here, test methods. Here's the auto-wired proxy, which is going to be connected to the quotes proxy that we talked about. Here's the before all annotation that says this setup method is going to be called before any of the tests run. And what that's going to do is going to go ahead and parse the options that we give this. We call them command line options. They're really not on the command line, but we want to turn on debugging is the basic point of that. And then we've got one test only called test get all quotes with backpressure. And here's how this works. We're going to test both zippy and handy quotes. We're going to get quotes from both zippy and handy lists. And to do this, we're going to have some real fun. This is a fun little example of using parallel flux. So we have a factory method called make quote subscriber, and we pass in zippy and handy. We'll look at make quote subscriber in just a second. And make quote subscriber is going to return a quote subscriber. And then we're going to run everything in parallel. So both of these requests will go on in parallel to the client. We're going to run that on the bounded elastic scheduler. We run this on the bounded elastic scheduler because these calls are going to be sending networking calls out there. And they're going to block. And they're going to block because we're going to use the await method in our blocking subscriber to wait for the things to finish, which is why we have to use bounded elastic. After everything's done running, we'll convert the parallel flux back to a flux, and then we wait for everything to process. So let's go take a look at this make quote subscriber factory method. This is really cool. So what it does is it takes the subscription type, zippy or handy, and it makes an instance of blocking a subscriber, which we're going to look at in a second. And it is going to go ahead and pass that blocking subscriber some Lambda expressions that will print out the values if everything goes well when we get quotes back, print out a failure message if we get an error, which we will not, and then print out that we're done when everything's completed. And the other thing we do here is we pass in as the fourth parameter to this constructor the request size. What is the request size? Well, the request size is an option that returns request size, which we can toggle. And that option is initially set to, I believe it's 5. There we go. So we have a value of 5. And that means that under the hood, using backpressure aware mechanisms in RSocket and Spring, it's in Project Reactor, it's going to transparently only get 5 messages at a time, which it will then consume, 5 quotes. And then it'll go ahead and have to ask for the next tranche of quotes. So that's how we set the backpressure value. We then go ahead and take that blocking subscriber, and we got a cool little stuff here we'll take a look at in a second. We're going to make ourselves a subscription request, which will have a random type, a random name rather, and whatever type, zippy or handy, we pass in. And then we go ahead and use our proxy to get all the quotes from that subscription request. So we'll have one of these going on in one thread that'll get all the zippy quotes, another thread that'll get all the handy quotes. But we're only going to take up to total number of quotes because we don't want to wait all day because there's like 600 of these zippy quotes and fewer number of handy quotes, but there's still a lot. And so we're only going to take up to a certain number. I think I set that value to 15. When this is done, we're going to send a cancel request to the server saying, I no longer want to be sent I'm no longer subscribed, rather. And so we send that in an unconfirmed way, so it doesn't require a response. And then we go ahead and we subscribe the blocking subscriber. So the blocking subscriber was created up here. And then we return that blocking subscriber to the caller. And so that blocking subscriber then is going to come back and be waited for by map. So a lot of this whole example hinges on what the heck is a blocking subscriber. So let's take a look at what the blocking subscriber is. So this is a backpressure aware subscriber implementation that will also do blocking, which is otherwise not well supported in Project Reactor. So blocking subscriber implements subscriber. It's got a bunch of fields to keep track of the various consumers and runnables that are passed as parameters to the constructor. These are the method references, or they're the Lambda expressions that get called back. We keep the request size, which is how many things we want to get before we have to say to the publisher, give me some more, please. And then we also keep track of the subscription, which is needed in order to be able to send that request back to the publisher. And then we've got a couple of other atomic variables that keep track of the number of events processed and the total number of events. This is for the window that we have for the request window. This is for the total number of events. And then the final field is the countdown latch, which will be used by the caller to make everything wait until the processing is done. The blocking subscriber constructor just sets everything up. It initializes the fields with the parameters, and it also sets the countdown latch to be 1. And then the various hook methods, which are just overridden from the subscriber interface, do various things. So on subscribe, when we're connected to the publisher, which in this case is the server running across the network, we tell the server, this is the number of events or the number of quotes I want you to send me before you have to wait for me to ask for the next chunk. So that's where we set that up through the subscription object, which we stash away. Here's the onNext method, and this is very cool. This is what actually does the backpressure logic. So when onNext is called back, that means that the client, the requester, has received a quote from the server, and it goes ahead and accepts it, which will print it as a side effect, increments the number of total events, and if the events processed thus far equals the request size, well, we've just exceeded our window. So now we have to go ahead and ask the publisher, the server, to send us another chunk of requests, and we reset the events processed thus far back to 0. So that's where the backpressure gets enabled. And then we go ahead and have onError, which just deals with error handling, onComplete, which deals with successful completions. And notice that the onError and onComplete methods both release the countdown latch because we're done at that point. OK, and then here's the await method. The await method just is used to block the caller until all this asynchronous processing finishes. So now that we've seen all of this stuff, and we've talked about the client beans, we talked about that before, so I won't spend a lot of time going through that. You can take a look at that if you are interested. Here's one thing we didn't talk about before, which I'll mention just briefly. Here's the connect response handler. This is what receives the handshake response back from the server saying, I have received your connection request. Here is my response to you, which just says connection accepted. And then we respond with an acknowledgement back to the server saying, thank you very much. The connection is now complete as far as I'm concerned. And you can see that that's a message mapping that is got the server response path, so the server's request will go to the right place. And this is basically connected up here in some places that are, here we go. You can see that that's set up here in the M responder, which is a socket acceptor. So that's the client bean stuff. Here's the client proxy stuff. We've already kind of talked about that, so I won't spend a lot of time on that. This basically does the client proxy behavior that we have here. One thing just for fun, I'll show you how we wrote the getAllQuotes method. This is the client proxy side. So what it does is it takes in the connection to the server. This is the mono to the server RSocket requester and the subscription request. And when they're both ready to go, it combines them into something called a tuple2 object, which it then passes to the getAllQuotes helper method. And let's take a look at what that does. What this getAllQuotes method does, just to make it a little bit more clear, it takes the tuple2, which has the requester and the subscription, breaks them up a little bit. So now we have the requester as a variable and the subscription as a variable. And then we say, make me a mono that has the getAllQuotes as the metadata and the subscription as the data, and then go ahead and send that to the server using retrieve flux. So that'll send this message to the server at this requester location. And then it says, I expect to get back a flux of quotes in response. And we use flatmap many to get those back as a flux. So we're kind of converting a mono, or taking a mono and turning it into a result that returns a flux. So now that we've seen all that stuff, let's go ahead and run the program. So I've very thoroughly annotated the output here, and I've got all kinds of clever things to make it easier to read so you can see what's going on. This is sort of munging both the client side and the server side into the same output window, which is because of the way the tests work. When you run a Spring Boot test, it launches the server implicitly and then also runs the client in the same window. And so this is what it's doing. You can see there's one test called test get all quotes, blah, blah, blah. And here's what it looks like. So when you enter a method, I use this syntax. And when you leave a method, then I have some other syntax. You can see like at the bottom, we're leaving the method. So we enter, we leave. And this stuff says, this is the blocking subscriber. This is on the client side. You can see that one thread is waiting for the async computations to complete, and a different thread is waiting for the other asynchronous computations to complete. Those, of course, are the zippy and handy computations that we're waiting for. Now, the next line over here, next lines, is actually on the controller and service side. This is on the server side. So we're entering the handle connect. We said we got a connection from a client at this UUID. And then we go ahead, and now we're back on the client. We get the response from the server saying the connection's accepted. And then you can see here that now messages are flowing. So subscriptions are done. Oh, here's the client's acknowledgement. The service gets the acknowledgement from the server gets the acknowledgement from the client. Some subscriptions have occurred. Everything authenticated right, because otherwise we wouldn't be doing anything here if we didn't have the authentication working. You can see that get all quotes is coming in for both handy and zippy. And so now we start to see, at long last, Backpressure. So now we're back on the client side. And on the client side, we're getting 5 zippy quotes, because we only get 5 at a time. And then we have to request the next chunk. Likewise, then we get 5 handy quotes. You can see it's going back and forth between the different threads. So we get 5 zippy quotes, then we get 5 handy quotes. And we have to wait for the next chunk. So that's happening on the blocking subscriber. So this is all client-side stuff. And then we get 5 more zippy quotes, have to wait for another chunk. Get 5 more handy quotes, have to wait for a chunk. And that goes until we get 15 of these things, and then we're done. And then it prints out that we got everything we expected, so that's finished. And then the final thing that happens is we shut everything down. And when we shut everything down, you can see here that that will go ahead and have the server side shut down all the various subscriptions. So all the subscriptions are then closed down at that point. And everything is freed up because we're done. So that's basically the walkthrough of this example. It's a very, very cool example, and it demonstrates a lot of the features that we've talked about from throughout the course, but it pulls it all together in the context of asynchronous reactive messaging, the integration of asynchronous reactive messaging in the context of Spring, and it also demonstrates the use of backpressure to be able to keep the server from overwhelming the client by only sending back a chunk at a time.